Welcome everyone. This is the third tutorial in the subject Mechanics of Solids. I am Sukanya Karmakar. I'm a fourth year PhD student in the Department of Civil Engineering at IIT Kanpur. Today, we'll be discussing questions based on the content which has been covered in the week 3 of this course. So, mostly we'll be focusing on deformation of like mechanics of deformable bodies, and maybe we might focus on on one or two questions on of trusses and friction. We'll be also looking at questions where friction is playing an important role. So let's start solving the questions. Hang on for a second. So let's start with the first question. So this is the system which I have. I have a wood diving board like this, and it is hinged at one end, and it is supported 1.5 meter from this end by a spring. So here it is supported by a spring, and you have a support something like this. This is 1.5 meter away, and this spring has a spring constant of 35 kilonewton per meter. And suppose the step ends here. Here you have water. Suppose there is a man standing at this point, right? And this is some 1.35 meter away. And this man weighs some 600 newtons. You have to find out how much will the spring deflect if because of this man. So find how much the spring deflects due to the weight of 600 Newton and this setup. So how will you solve it? Here, let's draw the free body diagram. So let this be point A, let this be point B where you have the spring, let this be point C. Here you have a point load of 600 Newton. Suppose here you have two forces, like two reaction forces, FAX, FAY, and you have a force here, spring force Fs. These are all the external forces acting on the spring. So let's mark the distances as well. This is 1.5 meter. This is 1.35. And let's assume that the deflection in the spring, like the deflections are small and the spring force remains vertical. It is not changing like the orientation. So let us assume the spring force remains vertical for small deflections. So here I want to find out the spring force Fs. For that, the easiest way will be to take the moment about point A. Then the force Fax and Fay will not appear in the moment equation and Fs can be calculated. So let's calculate the moment about point A is equal, summation of moment about point A is equal to 0. And let's take clockwise moment to be positive. So Fs into 1.5 minus 600 into this will be some 1.85 1 meter and 1 meter, so 1.5 plus 1.35. So from here you will get Fs to be equal to some 1140 Newton. Now you have to calculate the deflection in the spring and you know the spring constant. So from there you can calculate deflection because spring force is equal to spring constant into the deflection in the spring. So deflection in the spring is the spring force which is in Newton divided by 35 kilonewton per meter. This is 35 kilonewton per meter. So 35 into 10 to the power 3 Newton per meter. So Newton goes away. So answer is in meter. So if I want the answer in then let's multiply by 1000. So answer is in mm. So 1140 by 35. So it is 30. Okay, so from here we find out that the deflection in the spring is 32 mm because of the 600 Newton force. So a very straightforward question. Now let's move on to the next question. So here you have a 2.5 meter diameter sound baffle. Basically, you have a disc and it weighs 1.1 kilonewton, and it is to be hung from a ceiling with three springs which are mounted on a radii, making angle of 120-degree with each other. Uh, and these springs, each of the spring are 250 long, are delivered to do the job. And there are three springs A, B, and C. Spring A and B have a spring constant of 14 kilonewton meter, and C has a spring constant of 16 kilonewton. Okay. So first, let me draw the setup. So the plan view is something like this. You have three springs like this, and this. Here you have spring A, B, and C, and here if you view, this is spring A, this is spring B, this is spring C. And if you look at the plan view, that is, let's assume you're looking at this setup from the top, um, like in this direction. So this C spring, if like this, let O be the center. Let O be the center point. Then this angle, and this angle all are equal, and it is 120 degrees. So I hope this is clear. So you have a 2.5 diameter a disc, diameter sound baffle. If someone tried to enter, but left. Okay, so you have a 2.5 diameter sound baffle weighing 1.1 kilonewton, and it is hung from a ceiling with three springs. The springs make an angle of 120-degree with each other. The springs make an angle of 120 degrees with each other, and I've just shown here in the figure how they make an angle of 120 degrees with each other. And these springs, each 250 long, are used, and the spring constant of A and B are 14 kilonewton. So length of springs, sorry, Length of springs is equal to length of springs is equal to 250 mm, and spring constants Ka is equal to Kb is equal to 14 kilonewton per meter, and spring constant Kc is 16 kilonewton per meter. The springs A and B are mounted 1 meter from the center. We have to find how far from the center should the spring C be mounted if the sound baffle, that is this disc, has to hang level. That is, it should be straight. Like it should not, like one end should not go down, or one should, like it should remain level. So how much should like this spring C be away from the center so that it remains level? This is your question. If the springs A and B uh, um, are mounted 1 meter from the center, how far from the center, then how far from the center should the spring C be mounted? Should the spring C be mounted? If the sound baffle is 2 and level. So for this, for the sound baffle to remain level, it should remain straight. Then the deformation in the spring A, B, and C should be equal. This is the first thing which you should realize. This is the compatibility condition. Then from the equilibrium, we know that the force carried by the three springs is equal to the weight of the disc. From here, we can get a relationship. From using these two relationships, we can calculate how much force is being carried by the, like, what is the value of magnitude of the force carried by spring A, B, and C. And once you get the value of the spring forces, then we can find out the position of spring C so that it remains straight. Or in other words, mm, we'll be using force equilibrium for carrying out the spring forces. So for this baffle to remain level, we can use the moment equilibrium um, concept. So so let us so as I told you, for this back for from the geometric compatibility condition, for this baffle to remain straight, the deflection and the spring A, B, and C should be equal. So if delta A is the deflection in spring A, delta B is deflection in spring B, delta CN is deflection in spring C, all the deflections are equal, and this comes from geometric compatibility. Then from the force deformation concept, the force in, sorry, the force in spring A will be Ka into delta in spring B, and we have the value of K, Kb and Kc. Force in spring B will be Kb into delta B, and spring C is Kc into delta C. Now let's sum the forces in the vertical direction. Summation of forces, let's say this is the z-axis, this is x-axis and y-axis. So in the vertical direction, so Fz is equal to 0. So Fa plus Fb plus Fc, this is the force in the three springs, is equal to the weight. Weight is 1.1 kilonewton. Let's write the 1.1 kilonewton is the weight of the baffle. So Fa is, and also remember K and Kb for the, K and Kb for the two springs A and B is equal. So basically these two can be written as some Ka into, uh, and let's assume that delta A, delta B, delta C both all are equal. So let that be equal to delta. So this is equal to delta. So Fa, Fb both are equal to Ka into delta. So Fa is Ka into delta, Fb is also Ka into delta, and Fc is Kc into delta. So from here you can substitute Ka, which is um, 2 Ka delta plus Kc delta is equal to 1.1. Ka is 14, so 28 delta. Kc is 16, so 16 delta, 1.1. So delta is equal to 1.1 kilonewton by 28, 12, 14, 42. This is Newton per m 2000. You will get the answer in nm, and this comes out to be, just pulling up the calculator, 1.1 divided by 44 into 1000. So this comes out to be 25 mm. So from here we can calculate the force in spring A and B is Ka into delta. Ka is 14 kilonewton per meter into 25 by 1000. This is a meter. So the answer, what you get is in kilonewton. 14 to 5 divided. So 0.35 kilonewton, and Fc is Kc into delta. Kc is 16 kilonewton per meter, and this is 25 by 1000 meter. So 16 into 5 by 1000. So this comes out to be 24 kilonewton. Now, once you have the force in the springs, you can take the moment, write down the moment equilibrium equation about the point O. So, summation of m, summation of moment about the point O, because of this force along this direction, this and this. So, like because of the spring force, all the spring forces are parallel to the z-axis. So, basically, we are summing up the moment about point O. And the spring forces are parallel to the z-axis. So, uh, I sum up the forces. And all these spring like the disk lies in the xy plane, lies in the xy uh, so it's you can write down the forces in the vectorial format. So if this is, let's say, this is your x and y axis. This is your x and y axis. And your springs are at an angle of 120 degrees from each other. So let one of the force Fc lie here along this y-axis, and let this be center O. And this is what you need to find. Let me call this distance O. This angle is 90 degree, and one of the force A, it is, this distance is 1 meter. At this point, you have the spring. Now all the forces are in the z direction. So here is a FA is also in the upward direction, FC is in the upward direction. This is point A, and this angle should be 30 degree because the angle between the spring, like this total angle is 120 degree. So this angle which I just marked is 30 degree. Now this is going this direction also at a distance of 1 meter. You have the spring force FB, and this angle is also 30 degree. Then finally, if you take, if you write the moment equilibrium equation about this point O, so this vertical, this FC is equal to, okay, basically was trying to write it in the form of vectors. So FC is, let's try. Is my pen not working? It's better if I write the moment of this point O about the x-axis. That will be easier. So FC is at a distance of E, fine, and this is equal to FA, and the distance from point O, that will be 1 into sine 30. It's distance from the x-axis, 1 into sine 30. Similarly, FB is also at a distance of 1 into sine 30. So from here, FC, we already know. I want to find out E. E is equal to, if you plug in the numbers, FA is 0.35, FB is also 0.35, sine 30 is half, divided by FC is zero point 0.4. So E comes out to be some 0.875 meters. Okay. Now let's move on to the next question. You have a stiff horizontal bar AB, and it is supported by three springs, okay, with different spring constants. With the bar has to remain horizontal under the load P 1 kilonewton. You need to find out how much does the bar move, and spring constants have been given. So let me first draw down the setup. So this is your question number 2. Let's move to question number 3. So your setup is something like this. This is the first spring K1. This is the second spring K2. And here you have another spring K3. This is the bar AB, which has to remain horizontal. At a distance B, you have system. So you have a stiff horizontal bar AB, and it is supported by three springs with different spring constants. The spring constants are K1 is equal to 50 kilonewton per meter, and which is same as K2, and K3 is 100 kilonewton per meter. This bar AB has to remain horizontal. So with the bar AB horizontal under the load P is equal to 1 kilonewton, under the load P, and this P is nothing but 1 kilonewton, you need to find out how much does this bar move. Find how much does the bar move. So basically you need to find out the deflection of this. So for that, first thing which you can do is calculate the I'll try to be a bit louder, but why am I not audible? Please check your sound settings. From my end, it is fine. Okay. Like, is it better now? Is the voice better now? Okay. So Am I audible now? Can someone please confirm? Okay, I assume I'm audible. So let's start solving this question. Okay. Okay, just hang on for a second. Is the voice clearer now? Can someone please confirm? Hello? Can someone please confirm? Can someone confirm if the voice is clearer now? Until anyone, if someone does not confirm it, it's difficult. So let me wait for 5 minutes. then we can proceed. Am I audible? Can anyone please confirm? Okay, still the sound is low. Now, is it better? Is the sound better now? Like this is the maximum I could manage like within 5 minutes. Maybe from the next class I'll find a better solution. But is the sound manageable now today?
Yes, yes, it is now.
Okay, okay. So here, in this question, this bar AB, it's a stiff horizontal bar, and it is supported by three springs. Uh, the springs are K1, K2, and K3, and the spring constants have been given. And a load P, which is like 1 kilonewton, it's getting applied on the bar at this position, as I've marked on the figure. And this bar has to remain straight under this it has to remain horizontal. Under this constraint, you need to find out that on the application of this 1 kilonewton force, how much does the bar move? So, the first thing is we first need to simplify the system. Since the spring K1 and K2 are in series, like they are in series, meaning they carry the same value of the spring force will be equal with different amount of elongation in the spring. So sum of elongation in spring 1 plus sum of like if the elongation in spring 1 is delta 1, so delta 1 plus delta 2 will be the total deflection. So from this logic, since we know spring force is K into delta, so uh, spring force F by K1 plus F by K2 is equal to F by K equivalent. So from here we can calculate the value of K equivalent. And since it is since the spring K1 and K2 are in series, the forces are equal. So here K equivalent is the equivalent spring constant. Equivalent spring constant. So just plug in the numbers and get the value of K equivalent. K equivalent is 1 by K1 plus 1 by K2. So K equivalent comes out to be K1 plus K2. So K1 and K2 are both 50. So K square by 2K. So K by 2. So 25 kilonewton per meter. 25 kilonewton per meter. Now, this bar AB must remain. Okay, thank you. I hope from the next week I'll be able to sort out this volume issue. Thank you for pointing it out. Otherwise, I won't be able to come to more. Thank you. So this bar AB must remain horizontal. So from here the geometric like compatibility comes into picture. So for both for the bar to remain horizontal, the the amount of deflection in the spring 3 and the deflection in 1 and 2, it has to be equal. So here geometric compatibility comes into the compatibility condition comes into picture. So if AB is horizontal, then both springs deflect by equal amount delta. Deflect by equal amount delta. So um, let let me call this end A dash and B dash. So at the end A dash, so F A dash is K equivalent, or as I'm writing K effective into delta, and FB dash is K3 into delta. So here you have the spring force FA dash, FB dash, A dash, FB dash. The distance between FA dash and FB dash is A, and here you have the point load P, that is 1 kilonewton, and this is some B distance away. So first we can write the force equilibrium condition. we will use the equilibrium conditions. So summation of force in the vertical direction is equal to 0. So Fa dash plus Fb dash is equal to 1. Then we can take the moment about point B. If we take the about, let's say this point B dash and A dash. If we take the moment about point B dash, so Fa summation of moment about point B is equal to 0. So that gives Fa dash, it is at a distance A. In the opposite direction, you have 1 kilonewton force. It is at a distance of A minus B. So from here, Fa dash is A minus B by A, or 1 minus B by A. And okay, from here we can write delta is equal to Fa dash by K effective is equal to Fb dash by K3. So using this condition, Fa dash is this much. Fb dash will be 1 minus Fa dash. So 1 minus 1 plus B by A. So it's equal to B by A. So let's use this condition number 1. And that delta is equal to Fa dash by K effective is equal to Fb dash by K3. So if I put in the numbers, Fa dash is 1 minus B by A, and K effective is nothing. Should I substitute K effective? Yes. K effective is 25 kilonewton per meter. Fb dash is B by A, and how much is K3? K3 is 100. Now if I solve this, I will get B by A is equal to what should I get? B by A. B by A is 100 divided by 100 plus 25. Yeah, if we solve this, what did I do? I did 100 by 25 is B by 1 minus B by, right. Then what I did. So from here, I get this, right? So once I get this B by A ratio, I can calculate Fa dash and Fb dash. So uh, Fb dash is zero point 0.8 kilonewton. Fa dash is zero point 0.2 kilonewton. And we had to find out the value of delta. So delta is Fa dash by K effective. Fa dash is 0.2 by 25. This is in meters. 0.2 divided by 25 into 1000 will give me the answer of mm. So 8 mm. So the value of the deflection is 8 mm. I hope this question is clear. Now, I hope the voice is little better now. I'm trying to be a bit louder. So let's move on to the next question. So we are done with three questions. In this question, you have a small railroad bridge and it is constructed of steel members, all of which have a cross sectional area of 3250 square. A train stops on the bridge and the loads applied to the truss on the side of the bridge are as shown in the sketch. I'll just draw the sketch. We have to estimate how much the point R moves horizontally because of the loading. So this is the sketch. This is the truss. Here you have a point load of 270 kilonewton. Here you have a point load of 360 kilonewton. Here you have a load of 180 kilonewton. And again, here you have a point load of 270 kilonewton. These angles are 60 degree each. And this distance is 4.6 meters. This is point R. So we have to find, because of this application of load, how much does the point R moves horizontally. And it is given that all members have a cross-sectional area. All members have a cross-sectional area of 3250 square. Of steam is 207 GPa. We have to estimate how much the point R. We have to estimate how much the point R moves horizontally because of the loading. So the first step will be to solve the truss and to get the forces in the various members. I'm naming it like this: A, B, C, D, E, F. We need the force in the horizontal members D, E, E, F, and F R. Why we need them will be clear in just a second. So your first step will be, for solving the truss, you need the support reaction. So let's solve the support reactions. So you will have a reaction here and you have a reaction here. This is F dy F R y. Since there is no horizontal force acting on the truss, I am not marking the horizontal. You will, right, this F dx will be equal to 0 since no horizontal load is acting on the truss. Let's start solving the question. Here it is given summation of, like you can do summation of force in the vertical direction to be 0. So F dy plus F Ry is equal to, you have 70 kilonewton plus 180 plus 270 plus 360. Then you can write the moment about point R. Then let's take clockwise moment to be positive. So f dy is at a distance of 3 into 4.6 because there are three panels each of length 4.6 meter, plus you have a point load of 270 kilonewton, which is also at a distance of 3 into 4.6, plus this is in the opposite direction, this 270 kilonewton point load, so minus, again here you should have minus, so minus 180 into 2 into 4.6 minus 270 into 4.6 is equal to 0. So using these two equations, you will get f dy, like from this equation, you will get f dy is equal to 480 kilonewton. And if you substitute it back into the first equation, you will get f ry is equal to 600 kilonewton. Fine. Then I need to find out uh, the horizontal displacement at point R. So the horizontal displacement will be the sum of the displacement in the bar dE plus ER plus FR. So since we need to find the horizontal displacements, then total horizontal displacement will be displacement in bar dE and plus displacement in member EF plus displacement in member FR. Now we need to solve the truss. Here I'll be using uh, the method of joints. So let's consider joint D. The reaction is, like, basically write down the joint equilibrium. This is FDE, then let's assume FDC to be compressive, and you have 270 kg. Now let's do summation of Fy is equal to 0. So 480, this is taken as the positive direction, minus 270 minus FDC. This angle is 60 degrees. So sine 60 degrees equal to 0. From here you get the value of FDC. Then you write summation of Fx is equal to 0. So FDE is equal to FDC cos 60 degree. From here you substitute FDC and you get FDE is equal to 121.243. Here I'm skipping a few steps because we already studied how to solve trusses in the previous lecture. That is why I'm skipping some steps here. So like this, you need to solve the truss and you get the force in the member DE, EF and FR. So I'm directly writing down the force in the member EF and FR. So EF comes out to be this FFR is comes out to be 138.56. You can check this number later on. And EF force in the member EF is 259.81. So once you have these forces, we know that this derivation was done in the class that when you have an axial member, the deflection is PL by AE. So let's use this fact. So the deflection delta R will be this PL by AE of the member DE plus deflection in the member, whose formula is PL by AE in the member EF plus PL by AE, deflection in the member FR. So this is equal to, since the length of all the members is 4.6 meters, so 4.6 into 10 to the power 3 mm. Area is 3250 mm square, and the value of E is 207 GPa. So, like 207 GPa, so I'm converting it into Newton per, we should convert it into NPa, Newton per mm square. So I will have 10 to the power 3, right? And what is remaining is the force values in Newton. So substitute them: 121.24 plus 259.81 plus 138.56 into 10 to the power 3. So if you solve this, you will get this to be about 3.55 mm. I hope this question is clear. Now let's solve a question on friction. So this was question number 4. So let's move on to question number 5. So you have a vehicle kind of thing. These are two wheels. You can think of this as a vehicle of carrying a vehicle for carrying the goods. So a mine car kind of thing. But let's say, and here it is being pulled with a force of 10 kilonewton, and from here, from this level, it is at a distance of 0.9 meter. This is point B, this is point A. This dimension, this radius of the wheel is 0.15 meter. From this point, this distance is 0.6 meter. This distance is 1.5 meters. And the question reads that this is a mine car and its contents have been shown, and it has a total mass of 6 mg and a center of gravity, and this force acts at the center of gravity G. So G is the center of gravity, and the total mass is equal to 6 mg if the coefficient of static friction between the wheels and the tracks is zero point 0.4 when the wheels are locked. We need to find the normal force acting on the front wheel at B and the rear wheel at A when the brakes at both A and B are locked. So if the coefficient of friction, if the coefficient of friction, if the coefficient of static friction, if the coefficient of static friction between the wheels and the tracks is zero point 0.4, between the wheels and tracks is zero point 0.4 when the wheels are locked, when the wheels are locked. Find the normal force acting on, find the normal force acting on the front wheels at A, from the front wheels at B, and the rear wheels at A when the brakes at, when the brakes at both A and B are locked. And we also need to state whether this car starts moving under this condition. Under this stated condition, does the car starts moving? So the first thing will be to draw the free body diagram of this vehicle and to find out the friction, the normal forces acting on the front wheel and the rear wheel. So, so you have a force of 10 kilonewton acting at this point, which is at a distance of 0.9 meter. Then you have the two wheels. Since the 10 kilonewton force is trying to pull the uh, the wagon in the forward direction, you will have in friction on the wheels in this direction. Like this VFB, this is FA. Then you will have normal reactions in B and NA, which is what you are required to find here. Then here, let's mark the distances. This distance in the question is given as 0.6 and the total is 1.5. So this has to be 0.9. And in the question, this is given that this is 1.5. And total mass is 6 mg is mega in that. So 6 into 10 mega, so 10 to the power 6. This is in grams, so 9.8 fun is this much Newton. No, this divided by 1000, this much kg into 9.81 divided by 10 to the power 3. So the answer will be in kilonewton. I hope this unit conversion is clear. Then you need to find out the reaction forces, like the normal force. So let's take the moment about point B. If I take the moment about point B, and let's take anti-clockwise moment to be positive. So NA is at a distance of 1.5 plus 10, which is at a height of 0.9 plus how much is this the radius distance? 0.15. So point like as marked in the question, it is not the radius, it is basically the distance, and I've not drawn the wheels properly. Let me redraw them. Like this distance is 0.15. Check whether I wrote the question wrong. Is it mentioned anywhere in the question that this is the radial distance? Okay. Let's assume that this is 0.1. So this is 0.5. Yes, minus 58.86 into zero point 0.6 is equal to 0. So from here, NA comes out to be, just plug in the numbers, 58.86 into zero point 0.6 divided by uh, 15 point, this comes out to be some 15.54 kilonewton, and summing all the forces in the vertical direction. So NA less than B minus 58.86 is equal to 0. From there, NB comes out to be 42.3 kilonewton. So we have found out the normal reaction. Now we have to check whether under this stated condition, does the vehicle start moving? For that, we need to find out the value of the friction forces. And one thing I'll just like to highlight, like when we are taking the moment about point B, like we are not considering the value of this friction. Why are we not taking them into account? Uh, Basically, I'm taking moment about point, this point. If I mark them about this point, right? Then it is now. I am taking the friction force also into account, which is fine. I was just imagining that I am taking the moment about this center of the wheel. That is not the case. Then everything is fine. This is how we get the distance and all. I should have marked that point before itself. Now let's find out the friction force FA and FB. Now both the wheels are locked. Then the coefficient of friction is 0.4. So FA will be 0.4 into NA, that is 16.5 kilonewton, and FB will be zero point 0.4 into 42.3 kilonewton, which is this is some 16.9 kilonewton, and this comes out to be some 6.6 kilonewton. So total horizontal restraint from the two uh, friction forces FA plus FB is 6.6 plus 16.9 is equal to 23.5 kilonewton, and which is greater than 10 kilonewton. So since the frictional resistance is more, the mine car does not start moving. So the wheels do not slip and the mine car does not move. And the car does not. I hope this is clear. So let's move on to the next question. Move on to question number 6. So the setup is something like this. You have a plate like this. Then you have one more plate like this. Then you have one more plate like this. And all the three plates have been like tensioned together, like they are kept in place by using, you basically have four bolts. Here you can see only two bolts, but if you see this in plan, in this line you have two bolts, in on this line also you will have two bolts. So this is the kind of system which you have here, and here you are applying a force of P. Here you are applying a force of P by 2. Here you are applying a force of P by 2. And the question, in the question, you have to determine the maximum force P that this connection can support so that no slipping occurs between the plates. So determine the maximum force P the connection can support so that no slipping can occur between the plates. No slipping can occur between the plates. In the also, it's given that there are four bolts used for the connection. and each is tightened so that it is subjected to a tension of 4 kilonewton. There are there are 4 bolts used for the there are 4 bolts used for the connection, right? And each is tightened and each is tightened so that it is subjected to a tension of 4 kilonewton. So that it is subjected to a tension of 4 kilonewton. The coefficient of static friction between the plates is zero point 0.4. The the coefficient of static friction between the plate is 0.4. So let's quickly take a break of 5 minutes and we will come back and discuss this question. review session in about a minute. Okay. So I hope I'm audible. Okay. So as mentioned that here there are four poles and each bolt has been is subjected to a tension of 4 kilonewton. So what is the value of total normal force? The value of total normal force, since there are four bolts and each bolt has 4 kilonewton tension, so 4 into 4 is equal to 16 kilonewton. So first, let me draw the free body diagram. Say I'm drawing the resultant. What is the value of total normal reaction? 4 volts into 4 kilonewton is equal to 16 kilonewton. So the value of the friction will be the value of the friction force will be the coefficient of static friction 0.4 into 16, which is, sorry, 6.4 kilonewton. And then if I write the equilibrium equation, that summation of Fx is equal to 0, then P by 2 is equal to Fx. That is P is equal to 2 into 6.4, which is 12.8 kilonewton. Let's look at the next question. So this is question number 7. You have a 5 kg cylinder suspended from two equal length cords. So suppose here you have a bar kind of thing, and here you have one ring, here you have another ring, and from here you have a ring, and from here a cylinder is hanging. This inclined length is 600 mm, and this is also 600 mm. So a 5 kg cylinder is suspended from two equal length cords as shown in the figure. The end of each cord is attached to a ring of negligible mass that passes through a horizontal shaft. If the rings are separated by the greatest distance, D, this is the greatest distance, and D is equal to 400 mm, and still support the cylinder, we need to determine the coefficient of static friction between each ring and the shaft. So the 5 kg cylinder is suspended from two equal length cords, is suspended from two equal length cords end of each cord is attached to a ring. The of end of each cord is attached to a ring of negligible mass, that passes along a horizontal shaft, that passes along a horizontal shaft. If the rings can be separated, if the rings can be separated, can be separated by the greatest distance, by the greatest distance, D is equal to 400 mm and still supports the cylinder, and still supports the cylinder. We have to determine the coefficient of static friction. Determine the coefficient of static friction. Coefficient of static friction between each ring and the shaft. There is also a second part to the question, that is, if the coefficient of static friction between each ring and the shaft is 0.5, we have to determine the greatest distance d by which the rings can be separated and still support the cylinder as shown. So this is the first part of the question. The second part of the question is, if the coefficient of static friction between the ring and the shaft is 0.5, we have to determine the greatest distance d, the greatest distance d by which the rings can be separated. The rings can be separated and still support the cylinder. So let's start solving the question. So first, we'll write down the equation for equilibrium of the cylinder and find out how much is the tension force in the pot. First, we'll write down the equilibrium equation of the cylinder. Let's say the ring and cylinder is and time and the weight of the cylinder is 5 kg. So this is 5 into 9.81. This much newtons is acting in this direction. And you have a tension force T here. You have a tension force T here. And if I look at this triangle, like if I look at the configuration here, this length is 600. This total length is like 400, so 200 and 200. So basically, we know the angle as well. So uh, the, the two tension forces are must be equal since symmetrical. So summation of Fy is equal to 0. Theta, it will be 2t or theta minus 5 into 9.81 equal to 0. Theta. So let me have my calculator. 600 square minus 200 square. Square root of this number is 32 into 100. T cos theta is root 32 divided by this minus 5 into 9.81 equal to. From here, T comes out to be equal to, if I solve it, I'm getting 5.2 Newton. 5 point, sorry, for convenience, since I have the numbers in a certain format with me and I'm running out of time, let me call this n, and then later on I'll grab on. Then I'll be able to like provide you with that. I don't know why the behaves so weirdly, right? Okay, this is n, this is n, I'll give you the answers in also since I have two properties. 5.5. Okay. Then let's write down the equilibrium equation for this ring. This equilibrium equation or string. Equilibrium of ring. So here, let's write down the equilibrium equation. Let's write down the equilibrium equation for this ring instead of let's do it for this. So here, the normal force will be in this direction. You are pulling with the thread in this direction. So the ring is coming inward. So the friction will be in the outward direction. And the friction force is mu into n. You already know the value of T, which is 5.210. And uh, this angle is theta. Now, let's write summation of Fy for this ring. So n upward direction minus 5.m into cos theta. This again is 32 into 1000 by 100 by 600 is equal to 0. So here n comes out to be 4.905 and the value of normal force. Then you do equation of Fx is equal to 0. You will get there has to be horizontal equilibrium as well. So Fx minus 5.0 sin theta. And what is the value of sin theta? Sin theta will be 2 by second like 200 by 600. 200 by 600. Now frictional force mu into normal reaction. It is mu into 4.905 N minus 5.2 M by 6 is equal to 0. From here you get mu is equal to 0.35. Okay. This is the first part of the question. Moving on to the second part of the question. Given that you have a certain value of mu, you need to find out the distance of t. So again, let's take up the equilibrium of the ring. Here, the value of friction force, coefficient, the coefficient of friction is 0.5. Let's say the value of normal force is n. The t value not known. Value of friction is 0.5 n. So here we can write tan theta is equal to this by this theta is 53.43 degrees. Clear? Now
you already have this configuration. That this is D, this angle is theta, this angle is theta, the length of the chord is 600 and 600, and you need to find the value of D. So D is not the difference we can write. Cos theta will be E by 2. The D is equal to 2 into 100 into cos theta. You will get D equal to 500. 500. So these were the concepts which I wanted to type. The assignment which has been submitted, like they've already submitted them and the answers have been given. For the assignment one and two, if you're not able to understand, then please may write down an email to me and ask me. My email ID is kanya.k21@itgw.in. You may also ask, like in the current assignment, if you're stuck at a certain place and you're confused whether you're feeding in the correct direction or not, you may also write down a mail to me with your solution. I will be able to guide you whether you're in the correct direction or not. In this way, both of us learn. I also get to learn new approaches of solving a problem and looking at that problem. So it would be a very good experience. I hope this session helps you in solving that. I've tried to cover the concept of uh, like the mechanics of deformable bodies, where along with equilibrium you need compatibility and the force deformation relationship. You need to combine these three concepts to solve a question. We also solved a few questions involving friction and yeah, these are the two main areas which I have touched upon. And, yeah, so what I wanted to cover today. Again, I'm telling you, if you have any doubt, please please drop an email at happen to me. Thank you for attending the session. Next class, I'll try to solve this issue of volume. Okay, let's meet next. Thank you for attending. Thanks for attending session. I'll close the session out.